In today's GibbsCAM Tech Tip, we're going to display elliptical and interpolated turning. These are two powerful toolpath strategies in GibbsCAM. I'd like to show them to you and explain how to create them. Let's start with elliptical turning. The elliptical turn process in GibbsCAM will cut irregular radial shapes by attaching toolpath to selected surfaces. As I'll show, both outside and inside diameters are supported. This is done on a lathe with a y-axis. Also, the machine must be able to synchronize the c-axis of the chuck with the xyz linear axes. Let's start by cutting the OD of this ring. I have a saved process which I'll load. Let's look at the values in this process dialog to show you how to create this operation. Here are the entry-exit values. They feed the tool into and out of the cut. The machining tolerance is set to 5/10 of a thou. I'll set the pitch to 20 thou. This is the advancement of the tool in Z in one rotation. When we are happy with the shape of the toolpath, we can decrease this number for a better surface finish. Here's where you tell GibbsCAM where the toolpath starts and stops in Z. Here you can extend the start and end of the toolpath. We can leave stock on the surface or only in XR. The Optimize button is used to simplify the toolpath if the selected surfaces are prismatic. We can determine what type of surfaces they are by using Solid Inquiry. It is in the Plugins pop-down, or I have it here in a toolbar. By selecting on this face, we can confirm these are B-spline surfaces and non-prismatic. I'll keep the Optimize button unchecked. I'll select the surfaces using the Feature Manager. These surfaces were previously selected and grouped into the Feature Manager. Now I can quickly select them. Do it. Here we can see the tool cutting on the OD. You can see the tool moving in X, Y, and Z as the C-axis rotates. We can zoom in to check the surface finish. As I mentioned earlier, we can go back into the process dialog and tighten the pitch for a better finish. Okay, let's cut the inside diameter. I'll load the process. It's using a new tool. It's pretty much the same as cutting the OD, except an axis line is drawn at the center, so GibbsCAM knows from where to project the toolpath. This wasn't needed for the OD. I'll select the surface and the axis line and do it. Let's run simulation. Here again we get that nice synchronized motion. Okay, let me show you how easy it is to create an interpolated turn operation on this horizontal mill. Interpolation turning on a mill is where the tool rotates and the part doesn't. It is suitable for valves, manifolds, complex pipes, or any milling part with symmetrical features. Interpolation turning can cut on the OD, the ID, and the face. Also, it not only finishes but can rough with multiple passes. Interpolation turning will never compete with the efficiency of traditional boring and turning operations, but it is an alternative in some situations and can eliminate extra clampings. Your post files will require an adjustment for this operation. Talk to your local GibbsCAM reseller about it. I'll show you how easy it is to rough this face. First, here is a CS with the orientation required for this operation. It is the same orientation as the XZ plane would be on a typical lathe. Because we're on a mill part, it's the YZ plane. Let's extract geometry from the model using the profiler. Here is the tool and holder. Okay, That's all we need to create the process. Let's select the roughing process. Before I fill out any fields, I want to make sure we're using the correct machining CS. Here, the orientation of the tool looks good. We'll cut in a forward direction, front face, we're turning, cut depth, 0.1 inch. Here we set our speeds and feeds. CSS is off. We'll set both the entry and contour feed to 0.1 inch. This is the advancement of the tool in one rotation. We're using a stock model and it extends 0.25 inch from the face. So I'll put that value in here. I could use material only to optimize the toolpath, but I'll select full for now, so full passes are created. Here we'll leave 0.01 inch allowance for finish pass. Make sure Prefer Can stays off. The machine will require longhand code. Let's place the machining markers on the geometry. Do it. You can see the tool wants to cut into this groove. And just like in any turning up, we can inhibit axis motion. I'll deselect Z negative and redo. Let's run Machine Sim. You'll see the spindle moves in X, Y, and Z, and the C axis is synchronized with the move to keep the tool tip pointed inwards. Okay, let's rough and finish this bore. The casting has a through hole. We'll create a roughing process with this tool. This time, we'll cut the front ID. Turn. Our cut depth will change to 0.05 inch. The through bore on the stock model is 1.58 inch. I'll set the entry-exit clearances a little smaller. Everything else looks good. Let's put the machining markers on the geometry. Before I run simulation, let's create the finishing op. I'll change the process to contour. I'll set the entry-exit to 0.025 inch. The tool will feed into the cut at this slower feed rate. Let's create the operation. To better see the tool cutting, a cross-section of the stock model is in the body bag. We'll define it as stock and run the simulation. Thank you for watching today's GibbsCAM Tech Tip. For more information about elliptical and interpolated turning, contact your GibbsCAM reseller.